Hello everyone. Let's start solving this question which came in by weekly contest 173. So the question is minimum subarray length with distinct sum at least k. So you are given an integer array names and integer k. So we have to return a minimum length of subarray with sum of distinct values present in that subarray. Each value counted once is at least k. If no such subarray exists, return -1. And a subarray is a contiguous, non-empty sequence of elements within an array. So we have to find the sum of subarray, okay, sum of distinct elements in that subarray, and it should be at least k. That means it can be greater than k, okay, and we have to return the minimum length of such subarray. So if you see this example 2, 2, 3, 1 and k is 4, so the sum of distinct elements in subarray should be what? Should be at 4 or greater than 4. So if you see this 2, 2, 2, 3, if you consider this subarray, and what we have to do is we have to consider only distinct elements. So the sum is 2 plus 3, 5 and the size is 3. But again, if you see this, the sum is 5, which is greater than k. But, okay, but the length is less than the previous one, that is 3, and this is 2. And that is why the answer is 2, because in the question it is given that we have to return what? We have to return the minimum length of subarray. Okay, now let's say this example 3 to 3, 4. So the size is 2. Okay, size can be, see, at least k, right? We want at least k, so we have to minimize that size. Okay, now let's see how we will solve that solve this question. Is I'm explaining in this. Let's say this is our example. Okay, this is our nums array. So, what will be the first or brute force approach? It is like finding all the subarrays, okay, in an array, and then consider distinct elements, find the sum, and check the sum if it is at least this, and maximize the minimize the value. But that will not a optimal approach. So, what we will do, we will be using sliding window plus we will be using map. Okay, we will maintain a frequency map. So let's keep aside frequency map as of now, okay, and consider sliding window. What is sliding window is, we are consider sliding window. There are two different approaches. One is with fixed size, one is variable. So here we will be implementing the variable one. Okay, I will use two pointer. Okay, in sliding window, I'll use two pointer. One will be my left, one will be my right. Okay, now what I will do is till I get the sum. Okay, if I have sum greater than or equal to this, then I will stop there and I will again calculate this. Let's say, okay, let's do this. Here my sum when my left is 0, okay, and my right is 0. So let me write the indexes here: 0, 1, 2, 3, and 4. Okay, these are my indexes. Okay, when my left is 0 and right is 0, in that case, what is my sum? Let's take sum also. What is my sum? Sum is 1. Okay, now when my left is same, I will move right. Right is 1, that means I'm going to this. What is my sum from left to right? Is 3. Okay, now I will increment my right as 2. Why? Because my sum is still less than k. Okay, so we have to do this. My right is here now. Again I should increment this, but it is repeating. Okay, for this we will maintain a frequency map. Okay, so I will explain that while coding. So consider, we are not considering this element 1. So my right will move to 3. Why? Because sum is still less than k. So now we have this three element and I will add, I got 6. Okay, I got 6. It can be 7. Okay, it can be 8. It can be greater than k as well. Okay, some can be greater than k. But we got some 6. So what we have to do is we want to minimize, right? We want to minimize our length. As of now, what is my length? My length or my answer is right is 3, 3 minus 0 plus 1 is 4. My size, length size is 4. That is from this to this. This is 4. I want to minimize this. So what I will do, I will move my left forward. I will move my left forward and I will see if my sum is still greater than or equal to k. If it is less, okay, if it is less, we will stop there and we will move forward by right. Okay, if it is less, we will move forward by right and again get the sum as less the greater than or equal to k, and again do the same thing. So now what we'll do, we will move left forward. Okay, my left is 1 now. So what I want to do is I want to reduce this one, okay, from our sum. But it is already there here, right? We haven't added this, so we don't need to reduce. My sum will be still 6. Okay, now again my sum is still 6. I reduce? I will check. Okay, then what I will do, I will and we want to maximize, right? So my answer was this. Okay, now my answer will be here. If you see, after this what was my answer? 3 minus 1 plus 1 is equal to 3. So my answer is 3. Okay, next answer. Now if I move forward from this place, so 2 is there, I should subtract 2. So my updated sum will be 4, which is less than k. So what we will do, we will move forward right. Okay, we will move forward right as to 4. So my sum will be 8. Okay, my sum is 8. Again my answer, my next answer will be, okay, let me write this. Okay. My next answer will be what? Is 4 minus 1, 4 minus 1 plus 1, which is 4. So length is 4. So this can be my subarray, which has unique elements, and the sum is not this one. I think my right is 4 and my left is 2. I missed this. Yeah. So my this will be 3. Okay, here it should be 2. Okay, now the size is 3. 1 plus 3 is 4. 4 plus 4 is 8, which is greater than k. Okay, we don't want the exact sum, but we want it can be maximum. Okay, my next answer is 3. Now I can move, as my sum is greater than or equal to k, I can move this. So if I move here, okay, okay, if I move to this side, 3, my left is 3, my right is 4, my sum will be, we will subtract this one. Okay, so my sum will be 7, and still I have this. So I will check again. I want to minimize. So what we will do is again 4 minus 3 plus 1 is what? 2. Okay, two size subarray which has distinct element and the sum is greater than or equal to 6. Again I will do, I will move my left to right because my sum is still greater. So I'll go to 4. My sum will be 4, which is less, so we will stop, and there is nothing in right and nothing in left. Okay, so we will stop. My answer will be 2. Okay, this will be my answer actual. Okay, 3 plus 4 is 7. Do not consider this was our answer. The answer was 2 because the size is 2. Okay, so you got it. So we will maintain a frequency array. We will maintain left, right, sum, and we will do this till my sum is greater than or equal to k. Now let's start coding. So what we will do is we will take a map for frequency. Okay, mp is equal to new hash map. Okay, yeah. Now I'll take one int left is equal to initially 0, int answer is initially maximum value integer dot max value. Okay, and int sum is 0. My answer is length. Okay, so for int right is from 0, right less than n, that is nums dot length, right plus plus. Okay, now what we'll do, I'll take int value as nums of right. Okay, now that value we will add or not in sum, we will check based on frequency. So what I'll do, we have taken name mp dot what put, we will put this value and its frequency. So what I'll do, mp dot get or default. Okay, so if value is not there, I want this 0 and I'll do plus 1. Okay, plus 1. Now if my mp dot get value, if it is equal to 1, that means first time we have added, so I will add this value in sum. Okay, so plus equal to, why it got added this, plus equal to value. Okay, now what we have to do, we have to check my while my sum is greater than or equal to k, so we can minimize this the length. Okay, so what I'll do, answer is equal to mat dot minimum answer comma right minus left plus 1. Okay, now int, now we want left value. Okay, we want to reduce, right? So I will take my left value is equal to nums of left, nums of left. Then what we'll do, mp dot put this left value comma my mp dot get this left value minus 1. Okay, we will reduce. And if it is, what if it is 0, that means it was the only one, there is no occurrence. Okay, so we have to reduce it from our answer. So mp dot get left value, if it is equal to 0, then what we will do, we will subtract from this left value. Okay, and again we will, what we'll do, we will go one left plus plus, so we are coming forward and that's it. Yes, now what we will return, we will return my answer if it is equal to integer dot max value, because initially it was there no. So it, if it is equal to this, so we have to return minus 1, else I want answer to be written. Now let's run this. Why? Because in the question it is given that we have to return minus 1. Yes, accepted. Let's submit this solution. Yes, it is accepted. So thank you so much for watching this video. If you feel this video is helpful to you, please like this video, subscribe my channel, stay updated. Thank you.